This lesson is on factoring tips for second-degree polynomials in the form of ax squared plus bx plus c, otherwise known as quadratic expressions. Step 1 is we look at this expression in the form ax squared plus bx plus c, and we factor out any common factors of the coefficients a, b, and c. If they were all divisible by 3, you would divide that out first. It doesn't go away, we just factor it out and put it with parentheses as we factor it out. I'll show you an example of that in just a few moments. After we've factored out a common factor, we're left with the a and the c. We multiply those together and we would get some product. And we make a t-table, and on the left side and the right side we write factor pairs of that product. And then we look at those factor pairs, and we look at the sum of the different factor pairs to determine which pair, when added together, will equal the b. Once we find the particular pair that this works out for, that the sum of them is going to equal the b, which is up here, this b that's in the quadratic expression, then we write it in this grouping form here where we've got still the first term, ax squared, and instead of bx we write it as the sum of these two factors that would equal the b plus the c. And we put groups around each pair, and we're going to do factoring by grouping. It's best if we just look at a specific case, so a couple of examples, and it will help explain all of this. So here's your first specific case. We've got 6x squared plus x minus 12. There's no common factor, so we set right away and we just take the a, that is the 6, and the c, which is negative 12. We multiply those and we get this product, which is negative 72. We list each factor pair, so 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, and 8 times 9. Those are all the factor pairs for the number negative 72. Recognizing that one of the factors would be positive and one factor would be negative. We don't know which one, we just know that one will be positive and one will be negative. And we're looking for that particular factor pair that when you add them together, the answer will be 1. Well, if one's going to be positive and one is negative, that's similar to just saying, well, I'm going to subtract each pair and find out where is the difference between these two numbers, 1. Well, the only pair that has a difference of 1 is 8 and 9. So I know that these two numbers, 8 and 9, that's the factor pair that we're interested in. So I'm going to split up this x, this middle term, this plus x, as the sum of those two factors. So I put those in, 9 and negative 8. And then I put parentheses for my grouping. And once grouped, I'm going to do some factoring of those groups. And I notice in the first group, both 6x squared and 9x are divisible by 3x, so I factor it out. In the second group, I notice that negative 8x and negative 12 are both divisible by negative 4, so I factor that out. Once I've done that initial factoring, I notice that both of these, what was this one group, 6x squared plus 9x, there's a common factor of 2x plus 3 here and 2x plus 3 here. So I factor that out. And what I'm left with is 3x minus 4. And you'll notice that since this is a product of two groups, that I have indeed factored the polynomial. And the answer is 2x plus 3 times the quantity 3x minus 4. So we've factored it. Let's look at our next problem. In this problem, I see my ax squared, I've got a 4, plus my bx, which is 6x, plus c is negative 18. And the three coefficients, 4, positive 6, and negative 18, are all divisible by 2. They all have a common factor of 2. So I'm going to factor that out. Note that the 2 did not go away. It didn't disappear. I just factored it out, and it's out being multiplied, you could do by distributive property and get back to the original polynomial that we had up here. So it's just hanging out here outside of the parentheses, knowing that that's the operation of multiplication. I'm now just going to turn my attention to what's inside the parentheses and factor this trinomial right here. So I take the coefficients 2 and -9, the a and the c, and I multiply them, and I get the product of -18. I make my factor tree, and I have the factor pair of 1 and 18, 2 and 9, and 3 and 6. I notice again that I've got a negative product, so therefore I have one factor that will be positive and one factor that will be negative. And their difference, or the sum of them, since one will be positive, one will be negative, we're looking at the difference, has to be this 3 in the middle there. We want two factors add together and give us 3x. And we know that that would be -3x and +6x. So I write my grouping out here. Now it might look a little complicated. We had the 2 that we had from the outside still hanging out here. And then we have the ax squared. These two, the -3x and the 6x, are equal to the b, which was +3x. And then we still have the c, which was -9. I then did groupings of 2. And I'm going to look at what's common in each of those groups. And in this first group here, I notice that both of these terms have a common factor of x. So I factored it out. In this next group, I'm looking at what's common between 6x and -9, and it's a 3. So I factored out the 3. And now I notice that I have a 2x minus 3, and I have a 2x minus 3. So I'm going to factor that out. And all of this is still going to stay within this whole group of parentheses. It's going to be in that large parentheses. So I factor out the 2x minus 3, and what's left behind is the x plus 3. And that is the final answer for the original polynomial, 4x squared plus 6x minus 18. When it is completely factored, we get this factored form of the quadratic expression. So this is just a few hints on how to factor these. Main thing is factor out what's common, then take your a and your c, multiply them together and you get a product. Do your factor pairs, find the pair that adds together to make the middle term, the bx, write those factors, and then factor those groups, and you'll be done.